If you've ever looked up at the night sky, you've definitely seen it. That gentle, shimmering dance of a distant star. It's a sight that's captivated people for, well, forever. But here's a surprising fact. The twinkling you're seeing, it isn't actually happening.
That's right, the stars themselves, these incredibly distant suns, are burning with a remarkably steady light. That beautiful flickering we see isn't happening out there in the depths of space. It's an illusion that's created much, much closer to home. So what's really going on? To answer that, we have to follow a single beam of starlight on the very last moments of its long, long journey to Earth. The secret, it turns out, isn't with the star, but with the very air right above our heads.
All right, first, let's be clear about what we mean by twinkling. From a scientific perspective, the shimmering illusion has a specific name, and it's made up of a few distinct effects that you've probably noticed.
The scientific term for twinkling is scintillation, and the most important part of that definition is the phrase, "as seen from Earth." That little detail confirms that this isn't something the star itself is doing. Nope, it's an effect created entirely from our unique vantage point right here on this planet.
Scintillation is really a combination of three things. First, the star's brightness seems to flicker, going from bright to dim and back again. Second, its position appears to jump around, or dance just a little bit. And finally, sometimes you might even see quick flashes of different colors, especially if the star is low on the horizon.
Okay, so if the star is shining with a steady light, what's causing all this distortion? The answer lies in the incredible journey that starlight takes to reach our eyes.
For almost its entire trip, which can last for millions of years, starlight travels through the empty vacuum of space. And in that environment, its path is perfectly straight and its light is totally constant. That beam of light is completely undisturbed. The disruption, the twinkling, it all begins in the last tiny fraction of a second of that journey. It happens when the light finally enters the thin layer of air that surrounds our planet. Our own atmosphere is the culprit.
You see, our atmosphere is far from a calm, uniform bubble. It's actually a dynamic and pretty chaotic place. Think of it like a turbulent ocean of air, with pockets of warm air rising, cool air sinking, and all of it being swirled around by shifting winds. This creates countless little pockets of air with different temperatures and densities. As starlight zips through these different pockets of air, its path gets bent just a little bit. This bending of light is a process called refraction. And because the atmosphere is so turbulent, each pocket of air acts like a tiny, invisible, shifting lens, altering the path of the light over and over again on its way down to the ground.
A really good way to visualize this is to imagine looking at a coin at the bottom of a swimming pool. If the water's surface is rippling, the coin seems to shimmer and jump around, right? It's not because the coin is moving, but because the moving water is constantly bending the light from it in different ways. Our atmosphere does the exact same thing to starlight. Now this brings up a really important question. If the atmosphere bends all light that comes through it, why do stars twinkle but planets don't? The answer has to do with how far away they are and how that changes the way we see them. Because stars are so incredibly far away, all of their light reaches us as a single tiny point. Planets, on the other hand, are much, much closer. So even though they look small, through a telescope they appear as tiny disks, not just points. This distinction is the key.
So for a star, since all the light is coming from a single point, its entire beam can be bent away from our eye for a split second by a single pocket of turbulent air. That makes it seem to dim or even disappear for an instant. When the beam is bent back toward us, it brightens, and that rapid-fire change is what we see as twinkling.
But for a planet, light is arriving from many different points across its little disk. So at any given moment, the atmosphere might bend light from one side of the planet away from us, making that part dimmer. But at the exact same instant, it might bend light from the other side toward us, making that part brighter. All these tiny distortions average each other out, so the planet's overall brightness stays nice and stable. So while this atmospheric effect is beautiful to look at, it's actually a pretty big problem for scientists who need the clearest possible view of the universe.
You see, the very same scintillation that we call twinkling is, to an astronomer, just a form of distortion. When they use powerful ground-based telescopes, this atmospheric turbulence blurs the images of distant stars and galaxies, which really limits how much detail they can see. To get around this, astronomers have developed some really clever solutions. They build observatories on high, dry mountaintops where the air is thinner and calmer.
They use incredible technology called adaptive optics, where flexible mirrors change shape hundreds of times a second to cancel out the atmospheric blurring. And of course, the ultimate solution is to launch telescopes into space, completely above the atmosphere, like the famous Hubble and James Webb Space Telescopes. So, as we've seen, the twinkling of a star isn't really about the star at all. It's a story about light and its final turbulent encounter with our own world. So the next time you see a star flickering in the night sky, remember what you're really seeing. You're not witnessing a change in the star itself. You're watching the direct, visible effect of our own atmosphere moving and churning miles above your head, bending a beam of light that has traveled undisturbed for eons. This whole phenomenon is just a simple but pretty profound reminder about perception. The starlight itself is constant. It's the medium we view it through, our own atmosphere, that creates the beautiful and, in a way, deceptive illusion of a twinkling star.
The world is just full of things like this, where what we see is shaped by the journey it takes to get to our eyes. Understanding why a star twinkles is a great reminder to always think about that space between an object and our perception of it. It really makes you wonder, what other illusions are out there, hiding in plain sight, just waiting for us to understand them?